So now this video discusses about how we can derive the equations of kinematics and therefore the motion of the object in a straight line path, that is linear motion. So we understand that we have several ways in which the motion of the object can be analyzed. So we talked about the motion diagrams. You know, the motion of the object can be analyzed using what we call as the motion diagrams, and I will also call it as the pictures. So the motion of the object can be analyzed using the pictures, and we also talked about the graphs. Now, apart from using the graphs and the motion diagrams to describe about the motion of the object, you can also use what we call them as equations of kinematics. So equations of kinematics. So what are the equations of kinematics? So you need to understand that the motion of the object can be analyzed using the equations of kinematics under the assumption that the object is moving at a constant acceleration. Now, if the object is said to move at a constant acceleration, it means there is an equal rate of change of, a velocity per unit time, that is a constant acceleration, which means at each and every point, acceleration is the same. It's no longer changing. Just like though you can say object moving the constant speed, at each and every point the speed is the same for the object. So if the object is moving at a constant acceleration, it means at each and every point there is an equal rate of change of velocity per unit time. In other words, there is actual acceleration is constant for the whole entire journey. So assuming that the object is moving at a constant acceleration, then the following equations to be analyzed will be basically true and actually making sense in all aspects of the motion. Let's say we have an object. Let's say this is an object, and I say it is at a point A, and I'm moving towards this direction, like that. Let's say that is the case. And let's say at a point A, the object has been traced with initial velocity given as u. And after some time, let's say some time t, the object is now at a point, let's say this is a point B. Let's say this is a point B. Now with the new velocity I'll call it as a v. Let's say that is the case, I'll call it as a v. And let's say the distance covered from A to B, and for the object, let's say should be given as h. That's the displacement. Now since there is a change in the velocity from new velocity, actually from the initial velocity to the new velocity or the final velocity, it means the object has accelerated from A to B, and for that case the acceleration is towards the same direction. So with these 5 parameters, we can be able to analyze the motion of the object at whichever the point within the aspects of motion, and provided the acceleration is constant. So for that case, we can be able to find the distance traveled within the particular point in the aspects of motion. We can be able to have the velocity at whichever the point, and some stuff that are going to look up to. But now we'd like just have to concentrate on how we can derive the equations that can be used to analyze the motion of this particular object. Now the first equation you should have to understand, it's average velocity. We call it as the average velocity, and that is being symbolized as v bar. So what is the average velocity for the journey? So now the average velocity given as v bar will be given as the initial velocity plus the final velocity divided by 2. In much as we have 2 velocities, initial as well as the final. Now the velocity for the whole entire journey will be given as initial plus final divided by 2. That is the average velocity. And having the average velocity is just the same as the velocity, hence we'll have the velocity, which is for the average, being given as u plus v divided by 2. So this is what we call as the average velocity. So if we have the initial velocity as well as the final velocity for the journey, then the average velocity can be calculated using this formula. So that is. And apart from the average velocity, we can also have what we call as the average displacement. Average displacement. So how should you have the average displacement if that is the case? So now the displacement is given as s. So now the s bar, which is the displacement average, will be given as the average velocity times the time. You should have to understand that the distance is given as the speed times time. We are using this analog in the analysis of that case. So bear in mind that just having the average displacement, it is the same as the typical displacement. Hence we'll have the displacement is equal to, and having this average velocity is the same as this one. Hence we'll have it as u plus v divided by 2 and the times t. So this is what we call as the average displacement formula. So which means if we have the displacement, initial velocity, final velocity, we can be able to have the time. Likewise, if we have the time, initial velocity as the displacement, we can be able to have the final velocity using the formula as well. So that is. So I'll call this is equation number 1. This is equation number 2. So make sure you have somewhere to have the notes on whatever it is being expressed here. That is very helpful. And now another formula is what we call as the acceleration formula. That is the acceleration. So you should have to understand that wherever there is a change in the speed or the velocity, there is acceleration. And the acceleration is given as v minus u divided by t. And let's think of making v as the subject to have it as final velocity is equal to at plus u. This is equation number 3, and that is being obtained upon making the final velocity as the subject of the formula from the acceleration formula. So keep this in mind. So which means if we have the acceleration time takes as well as the initial velocity, you can be able to have the final velocity in the formula. Likewise, if we have the final acceleration initial, we can be able to have the time in that way. So take note of that. And we also have, should be equation number 4 by the way. We also have what we call as the displacement formula. So what is the displacement formula? We have the equation number 4, which is a displacement formula. So what is the displacement formula? So we understand that the average displacement is given as AC is equal to u plus v divided by 2 and the times time. And now we know that the equation number 3 is given as v is equal to at plus u. Now let's think of substituting this into this point. Now we have it as, now we can have it as the average displacement, which is equal to u plus at plus u divided by 2 and at times t. We'll have that. And what we'll have is, now what you can have is, we'll have it as the average displacement, which is equal to, now these are the like terms, we'll have it as 2, that will be 2u plus, that is 80 divided by 2 and the times t. Then we'll have to distribute the t, that will be given as the average displacement, and that is given as AC is equal to 2ut plus 80 squared divided by 2. And bear in mind that if we have, let's say, m times b over a, this is the same as mb divided by a, because some tend to confuse that this m will also be multiplied down here, which is incorrect. And for that case, you should have to understand that using the principle that says that if we have a plus b divided by m, this is the same as a over m plus b over m. If that is the case, then what we have is, we can have it as the displacement is equal to 2ut divided by 2 and a plus 80 squared divided by 2. Now at that point, we have it as the displacement is equal to ut plus half 80 squared. Now this is what we call as the equation number 4, and that is said to be the displacement formula. So which means if we have the displacement, rather if we have the initial velocity, acceleration, then we can be able to have the displacement using the formula. Likewise, if we have the displacement, time, acceleration, you can be able to have the initial velocity. And also, if we have the displacement, initial velocity, acceleration, we can be able to have the time, either using the quadratic equation if it happens that initial velocity is non-zero. So those are actually this is how we can derive the equations of kinematics. And mind you, these equations are being used under the assumption that the object is moving at a constant acceleration. And of course, it is not always true that the object can move at a constant acceleration, but this is just a typical assumption, and for the sake of the analysis. So again, here are the equations. We have the first equation, which is the average velocity. We have it as u plus v divided by 2, like that, where this is the final velocity, this is the initial velocity. And then we have another equation, which is the average displacement. We have the displacement is equal to u plus v divided by 2 and the times time. And we have the third equation, which is acceleration equation, but upon making v as a subject, to have it as v is equal to at plus u. And the fourth equation is the displacement equation, which is ac is equal to ut plus half 80 squared. And by the way, we are remaining with the 15th equation. So what is that one? Now, from the actually equation number 3, we should have to make d as a subject. So in this case, we have it as d is equal to, now that will be given as v minus u divided by a. That is if we are to make d as a subject here. Then now we should have to substitute this d into the second equation. What we'll have is we'll have it as the displacement is equal to u plus v divided by 2, and the times this d is the same as this d. We'll have it as v minus u, and that should be divided by a, and that is given as that. And if we expand that on, we'll have it as the displacement, which is equal to u times v, that is uv, and u times negative u, that is negative u square, and v times v, that is a positive v square, and v times negative u, that is negative uv, divided by 2 times acceleration, which is 2a. Now this and this will go since direct terms. So have it as the displacement is equal to, this is the same as having it as v square minus u square divided by 2a. And at this point, keep in mind that if we have, let's say, negative b plus a, this is the same as a minus b. It is the same as that, in case you may tend to wonder what's going on there. And having the cross multiplication, this is the same as 2a's, which is equal to v square minus u square at that point. Now if we think of rearranging the equation, this is the same as having it as v square is equal to u square plus 2a's. So this is the third equation of kinematics that you have to use. So praise the beginning of understanding the linear motion or the linear kinematics, has to start with being able to analyze these equations. So in all cases, given the typical question, just have to look at the given parameters in the question and you should have to compare which equation should we use based on the given parameters. So if the object is said to be moving from rest, basically initial velocity is if the object is said to be actually stop, final velocity is basically zero. So you just have to be very careful with the given parameters in the question, be able to understand what the question tries to emphasize. So next we're going to look at how we can use these equations of kinematics in some given typical problems. Thank you.